Hello, my name is Daniel, and today we will be going through the AMC 10A of 2007, and let's get right into it. First problem, one ticket to a show costs $20 at full price. Susan buys 4 tickets using a coupon that gives her a 25% discount. Pam buys 5 tickets using a coupon that gives her a 30% discount. How many more dollars does Pam pay than Susan? So there's one ticket at $20 and way too thick. $20 and 4 tickets, so 4 times 20 times it's 25% discount, so it's 3/4 that she has to pay. And yeah, this is Susan and Pam. 5 tickets, 5 times 20 times 30% discount, so it's 7/10. So this much is 60. This much is 100, so 10, 70. So 70 minus 60 equals 10. So Pam pays $10 more than Susan. Answer is 10. C. Number 2. A at B equals AB minus B squared. A hashtag B is A plus B minus AB squared. So do that with 6 and 2. It's basically 6 times 2 minus 2 square over 6 plus 2. So it's 8 minus 6 times 4. 24. So this is minus 16. It's in the denominator, and 8 in the numerator, which is minus 1/2. So it's A. Number 3, an aquarium has a rectangular base that measures 100 centimeters by 40 centimeters. So it's 4,000 cubic centimeters. No, 4,000 square centimeters. And it says how many centimeters does the water rise. So the height doesn't matter here. And the volume of this one is 8,000. So it's 8,000 centimeters. So it will raise by 2 centimeters since it's 8,000 is 4,000 times 2. So it's going to raise by 2 centimeters. It's D. Number 4, the larger of 2 consecutive odd integers is 3 times the smaller. So there's A, 3A, and then it's consecutive odd integers. So 3A minus A equals 2, right? So 2A is 2, A is 1. So we can see that this is 1 and 3. Their sum is 4. Number 5, a school store sells 7 pencils and 8 notebooks for $4.15. It also sells 5 pencils and 3 notebooks for $1.77. How much do 16 pencils and 10 notebooks cost? So we're just gonna have to figure out everything along the way, I think. So 7 pencils and 8 notebooks. 7 pencils, 8 notebooks, $4.15. 5 pencils, 3 notebooks, $1.77. Multiply by 3 and multiply by 8, so 21p plus 24n equals, what's 415 times 3? 1245. And then this one 40p plus 24n equals 177 times 8. 177, 8 was 56, and 8. So it's 1,416, 1416. So if you subtract these, then it becomes 19p equals 1416, 1245. So it's 170. It's 171. So P equals 171 divided by 19 and 81. Yes, it's P equals 9. So 1 pencil costs 9 cents. And so 16 pencils and 10 notebooks. If we get the P is 9, then put the 9 in here, so we can get that 7 times 9 is 63. 63 plus 8n equals 415. 8n equals 415 minus 63. This is 470. No, it's not. Why am I adding? 352. So it's 8 ends 352. This we can see that it's 32 times 11. So n is 4 times 11, which is 44. So 10 notebooks, it's 440. 16 pencils, 16 times 9, 54, 144. So 440 plus 144 equals 584. So it's $5.84. It's B. Problem 6. At Euclid High School, the number of students taking the AMC 10 was 60, in 2002 66, in 2003 70, in 2004 76, in 2005 78, in 2006 and 85 in 2007. Between what two consecutive years was the largest percentage increase? So 2002, 2003, 4, 5, 6, and 7. Between 2002 and then 2003, 6 increased, but there were when there were 60, and then 4 increased when there were, yeah, because it's 70 minus 66, so it's 4. 4 increased when there were 66, and then 70 and 76. So 6 increased when there were 70, and then 76 to 78. 2 increased when there were 76, and 85 minus 78, so it's no, it's not 13, it's 5, yeah, it's 7. 7 over 78. So we can right away see that these are all less than 6 over 60. Now we can compare these two, but then for this to have the numerator of 7, then it should be 70 at the denominator, and this is evidently bigger than 7 over 78. So 6 over 60 is the biggest, so it's between 2002 and 2003. It's A. Problem 7. Last year, Mr. John Q. Public received an inheritance. He paid 20% in federal taxes on the inheritance and paid 10% of what he left in state taxes. He paid a total of $10,500 for not, yeah, we don't know the unit over here. For both taxes, how many dollars was his inheritance? Actually, like, technically speaking, like it never said that it was in dollars, so yeah, we could argue, but let's just get to the point. So he paid a total of 10,500, so it's 20% of federal taxes. If you had X, then it's 0.2x plus 10% of what he had left. So he had left 0.8, but he paid 10% of that, so 0.0, so it's 0.1x. So it's 0.28x equals 10,500. X equals 10,500 times 100 over 28. So it's 10,500 times 25 over 7. So this is 71500 times 25. So it's 15, 25, 125, 25, 375, 37500. So it's 37,500. It's D. And number 8, triangles ABC and ADC are isosceles with AB equals BC and AD equals DC. Then let's just say that there is a line, and then we have AB, BC, ABC, and AB, AD. Oh, D is inside ABC, so D must be like this. And this must be D. Angle ABC measures 40 degrees. ADC measures 140 degrees. What is the angle measure of BAD? So they're telling us to find out this angle, right? But so let's see if this is 40 and these two should be the same. So BAC, angle BAC, this is 2 under 180 minus 40. This is 70. And then DAC, this is 180 minus 140 over 2. This is 20. So this is 70. This is 20. If you subtract them, it's 50. So it's 50. It's D. Problem 9. A and B satisfy the equations 3 to the A power plus 3 to the 8th power equals 81 to the B plus 2nd power and 125 to the Bth power equals 5 to the A minus 3rd power. So from this we can see that A equals 4, B plus 2, and 3B equals A minus 3. So from this, A equals 4B plus 8. 3B equals A minus 3. If we put this in here, then we can see 3B equals 4B plus 5, B equals minus 5, A equals minus 12. A equals minus 12. So what is AB? If you multiply them, this is 60, 60, not 16. So it's E. Problem number 10. The Dunbar family consists of a mom, a dad, and the children. Average age of the members of... Okay, so let's say that there are n children. The average age is 20, so it's 20 times n plus 2. It's the total of the ages. The father is 48 years old, and the average age of all the rest is 16. So basically this equals 48 plus 16 times n plus 2. N plus 1, I mean, since there's no father. And then 20n plus 40 equals 48 plus 16n plus 16. 4n equals 8 plus 16, it's 24. N is 6. So how many children? 6 children. It's E. Problem 11. The numbers from 1 to 8 are placed at the vertices of a cube in such a manner that the sum of the 4 numbers on each face is the same. What is this common sum? So the total is 1 to 8 sum, so it's 8 times 9 over 2. This is 36. So if you just look at a cube right here, then a cube, so the sum of the 4 numbers on the cube, they are going to be two faces contain all the vertices, and they have the same number on each face, right? So this equals 36, right? So this has to be split into 2 and equally, so it has to be 18, 18. So one face has 18, therefore it's C. Problem number 12. Two tour guides are leading 6 tourists. The guides decide to split up. Each tourist must choose one of the guides, but with the stipulation that each guide must take at least one tourist. How many different groupings of guides and tourists are possible? So there's the 2 tour guides, 1 and 2, and then let's just say A and B. And then there would be, each guy must take at least one tourist. So it's 1, 5, 2, 3, 4, 2, 4, 3, 3, 4, 2, 5, 1. It's until this one. How many different groupings? This is 6C, so it's 6 choose 1. This is 6. This is 6 choose 2. This is 6. Yeah. 6 choose 2. This is 3, 4, 5, 6. I don't know why I'm doing this right now. 4, 5, 6. I suddenly forgot. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15? 15. I think, yeah. 15, and then 3 would be 6 choose 3. This is 6, 5, 4 over 6. That's 20. 4 times 4. This is 6C4. Which this 6 choose 4. Same thing as 6 choose 2. 15. This is 6 choose 5. Same thing as 6 choose 1. So it's 6. If you add all of these together, and how many different groupings are possible? So it's 12 from these two, plus 30 from these two, plus 20. So this equals 62. So it's D. 13 yen is somewhere between his home and the stadium. To get to the stadium, he can walk directly to the stadium, or else he can walk home and then ride his bicycle to the stadium. He rides 7 times as fast as he walks, and both choices require the same amount of time. What's the ratio of yen's distance from his home to his distance from the stadium? So this problem is, so he rides 7 times as fast as he walks, but then if you look at the answer choices, they are, so the distances have one unit between them. So it's either a 2 and a 3 or a 3 and a 4. No, let's not be like this. So it has 1 unit between them, which must mean that if Yan goes straight on, then the time that he goes straight on will be equal to the distance that he goes back home and then rides his bike. But he rides 7 times as fast as he walks. So if we say that he walks at 1 meter per minute, and the Yen's distance says these are all in meters, then we can find for, so since he walks 1 meter per minute, then he will ride at 7 meters per minute. So he'll be riding 7 meters. So here, like 2 plus 3 is 5, 3 plus 4 is 7. So 7 comes up, and we have this suspicion that it's B. So if we think it's B, let's try it out. If Yen's here and he's somewhere between this much has 3 meters to go, this much has 4 meters to go, then actually it's the opposite. This much has 4 to go, this much has 3 to go. So if we just walk straight on, then it's 1 minute, then it's 1 mile. So sorry, it's 1 meter per minute, so it's 4 minutes. And then if he goes back and then comes, it's 3 minutes. 3 minutes going back plus 1 minute riding the whole 7 meters. 7 meters, so it's 1 minute equals 4 minutes. So it takes the same amount of time, so we can say that it's B. Problem number 14. A triangle with a side length in the ratio 3 to 4 to 5 is inscribed in a circle with radius 3. What is the area of the triangle? So if the side length are in ratio 3 to 4 to 5, it's inscribed in a circle with radius 3. So if there's a circle like this, and then there's this right triangle. Okay, so since it's a right triangle, so the hypotenuse has to be the diameter of the circle, and so the circle has radius 3, right? So the diameter is 6. So this much is 6. Let's put it in a different color. This much is 6. And now we have to figure out this part and this side. So this side, this is 6 times, by ratio, this is 5, 4. By ratio, this is 5, 3, 4, right? So it's 6 times 3 over 5. And then this side, this is 6 times 4 over 5. So this is 24 over 5, and this is 18 over 5. So the area of the triangle is 24 over 5 times 18 over 5 times 1/2. So it's 25 is under, and then over this is 12. 12 times 18. 18 times 12, 16, 36, 18. 216. So this would have been multiplied by 4 on both up and down on the denominator and the numerator, and then the denominator becomes 100. 216 times 4 is 24, 64, 864. So this is 8.64, so it's A. Problem number 15. Four circles of radius 1 are each tangent to two sides of a square and externally tangent to a circle of radius 2. So what is the area of the square? So if we look at this picture, then we can make the center of the circle here, and then we could connect them like so, and then connect these two, and then connect this two perpendicular, and then we will have a right triangle like this. So we're trying to find the area of a square, right? But then if this is 2 and this is 2 plus 1, no. So if this is 3, so this is 3, right? And then so this side, length of the side has to be 3 over root 2. And so this length is the same, so it's also 3 over root 2. This is the diameter, this is 1. This is also that's the radius, it's 1. This is also the radius, it's 1. So one side equals 1 plus 1 plus 3 over root 2 plus 3 over root 2 equals 2 plus 3 root 2. So 2 plus 3 root 2 square equals 18 plus 2, 18 plus 4 plus 12 root 2. This is 22 plus 12 root 2, and we can see that it's B. So the answer is B. Problem number 16. Integers a, b, c, and d, not necessarily distinct, are chosen independently and at random from 0 to 2007 inclusive. What's the probability that AD minus BC is even? So for AD minus BC to be even, then A, D, B, C are all odd, or AD and BC both even. And so for AD and BC to be both even, so let's consider the possibility for AD to be even. This is 0 to 2007, right? So this could be even and odd. Even and odd, this would be 1/4. Odd and even, this would be 1/4. Even, this would also be 1/4. So totally, it's going to be 3 over 4. So in total, it's going to be 3 over 4. Put this here. So probability of BC being even is also 3 over 4. So if you take these together, then both even. This is so you're multiplying them, right? So it's 9 over 16. And ADBC all odd. This means that this is 1/2. This is a half. This is a half. This is a half. So this is 1 over 16. If you put them together, if you add them, this is 10 over 16. And if you divide by 2 on both the top and the bottom, this becomes 5 over 8. 5 over 8, it's number E. E is the answer. Problem 17. Suppose that m and n are positive integers such that 75m equals n cubed. What is the minimum possible value of m plus n? So since m and n are positive integers, and it has to be n cubed, so 75, let's dissect 75 first. This is obviously 3 times 25, and 25, as we all know, it's 3 times 5 times 5. So for this to be something cubed, then m has to be at least 3 times 3, that's why 3 can be cubed, and times 5, that way 5 can be cubed. So this is 9 times 5, it's 45. So n equals 3 times 5, because there are because there's 3 pairs of 3 times 5, which means that it's 3 times 5 cubed, so n is 3 times 5 equals 15. M plus n, we could just add these together, and then we would get 60, so it's D. Problem 18, what's the area of quadrilateral ABCM? So for this one, I would also use coordinate plane and find for M. Since the line AG seems to be y equals minus 3x plus 3, and CH is y equals 2x, then here we could say that 2x equals minus 3x plus 3, 5x equals 3, so x equals 3 over 5, and so x equals 3 over 5. Keeping that in mind, the area of quadrilateral ABCM, so it's this part right here. So we could solve for this by getting to know this side, which is half of the whole thing, minus, no, we won't need that, yeah. So we won't need that. We could just do this triangle minus this bit. And so this x is 3 over 5 only when this is considered 1, right? So in real terms, m would be no, wait, m would be 5 over 3 times 4, right? So it's 12 over 5, comma, this is y equals 2x, right? So 2x, so it's 24 over 5. And then, if we solve for this one right here, then this is 4, this is 3 times 4, so it's 12. And then ABG, triangle ABG, the area of this would be 2 times, no, it would be 4 times 2, 4 times 6. This is 24, and so 24 minus this much equals 4 times, this is 4 minus 12 over 5, so it's 8 over 5. This equals 120 minus 32 over 5. This is 9, no, not 90, 88. 88 over 5, this is C. And problem 19, a paintbrush is swept along both diagonals of a square to produce the symmetric painted area as shown. Half the area of the square is painted. What is the ratio of the side length of the square to the brush width? So we were talking about the ratio here, and there was no mention of side length, so we can freely choose any side length that we want. Right now, I think I'm gonna go for 2. This side length is 2. Then the whole area would be 4, and the painted area would be half of it, so it's 2. Then the unpainted area would also be 2, and this is what we're going to be focusing on. So the unpainted area is this much, this much, this much, and this much. So if you if you say that this length here is a, then we can say that 2a squared equals 2. So that means a equals 1. So this would equal 1, and this length would equal root 2. So the ratio of the side length of the square to the brush width. So if we say that this is x, then this would also be x, right? So root 2 plus 2x equals 2. 2x equals 2 minus root 2. X equals 1 minus 1 over root 2. So it's, so it's 1 minus 1 over root 2. And then the brush width, that will be this much, right? But then if you look closer, then if you put a line right here, then this triangle would be a 45, 45, 90 triangle. So this length would be x root 2. So this is x root 2. This is 1 minus 1/2 times root 2 times 1 minus 1 over root 2. This is root 2 minus 1. So the brush width is root 2 minus 1. What's the ratio of the side length of the square to the brush width? The side length of the square is 2. The brush width is root 2 minus 1. And this is, this is root 2 and 2, and then multiply root 2 plus 1, root 2 plus 1, root 2 plus 1. This is 1. So 1, and it's 2 root 2 plus 2. This is 2 root 2 plus 2, and this is what we wanted, so it's C. Problem 20, the number A satisfies the equation 4 equals A plus A inverse. So this actually means A plus 1 over A, right? So 4 is A plus 1 over A. If you square this, 16 equals A plus 2 plus 1 A squared plus 2 plus 1 over A squared. 14 equals A squared plus 1 over A squared. And so if we square this again, it's 196. This is a to the 4th power plus 2 plus a to the 4th power under 1. So 194. This is a to the 4th power plus a 4th plus 1 over a 4th, which is a to the minus 4th power. So this is what we wanted. So the answer is 194. So it's D. Problem 21. Sphere is inscribed in a cube that has a surface area of 24 square meters. If a cube has a surface area of 24 square meters, then if it's A, and A, then 6A squared is 24. A is 2. So it's a cube with a side length of 2. A second cube is then inscribed within the sphere. Okay, so let's draw this thing out. If we have a cube like this, then it's said that there is a sphere inside of it. So this is the sphere, and the second cube is then inscribed within the sphere, so it would be touching the edges like that. So this edge would touch, and this edge would touch. And so this blue cube, that would, if we reposition it here like this, then we can see that from here to here, that's from here to here, this length is the diameter. This length is the diameter of the sphere, and the diameter of the sphere, since the side length is 2, the diameter is 2. But then if we say that the side length is x, then this length is root 3x. So root 3x is 2, and so that the surface area in square meters is so x equals 2 over root 3, and so the surface area is 6x squares, which is 6 times 4 over 3, which is 8. So it's C. Problem number 22. If a finite sequence of 3-digit integers has the property that the tens and the units digit of each term are respectively the hundreds and tens digit of the next term, and the tens and units digits of the last term are respectively the hundreds and tens digit of the first term. So so the example that they mention is that it's 2, 4, 7, 4, 7, 5. So these two are here, and 7, 5, 6. So these two are here, and then the next one will be 560. I don't know, 561 right here. Same thing, 61, 61. You get it. So that's 618, 182, 824. So it ends with 824. So that this is right here. But then one thing to notice here is these lines: 777, 555, 666, 111, 888, 222, 444. So they're asking for the largest prime factor that always divides S. But then if we add these together, then S is always divides by 111. And that's because the same numbers are here and here and here and here and here and here. So it's all being multiplied by 111. But then this is not a prime number, right? So we have to split this, and if we split this into 3 and some other thing, then that some other thing becomes 37. So the largest prime factor, because 37 is prime, so it's 37, it's D. Problem 23. How many ordered pairs mn of positive integers with m is greater or equal than n have the property that their squares differ by 96? So their squares differ by 96. This means that m squared minus n squared, since m is greater or equal to n, this is 96. But this is m plus n times m minus n, right? This is 96. And they are positive integers, so m plus n is always greater than m minus n. So it will be 96 to 1 and 2, 248, 3, 32, 4, 24, 6, 16, 8, 12. And so their squares differ by 96. And this would, and so let's check if any of these are plausible. So if we add these two together, these become 2m, so the sum would have to be divisible by 2. The sum of these are 97. It's odd, it doesn't work. This is 50, it does work. This is 35, it doesn't work. This is 28, it does work. This is 22, it does work. This is 20, it does work. So how many ordered pairs? There is 1, 2, 3, and 4. So it's 4 ordered pairs. It's B. Problem 24. Circles centered at A and B each have radius 2. Point O is the midpoint of AB, and OA is 2 root 2. Segments OC and OD are tangent to the circle centered at A and B respectively. EF is a common tangent, so we're trying to know the area of the shaded region. So if we see, we can put a line here, another line here, and then another line here. No, not a curvy line. Another line here, another line here. Yeah, and then that would make, this would be 1/8 of a circle, this would also be 1/8 of a circle, and so we would have this whole rectangle minus this part and this part, and also minus these parts. So in order to do that, we could be able to, wait, so first, each have radius 2, right? So this much is 2, and then OA is 2 root 2, and O is the midpoint of AB, so OB is the same thing. So it's 2 root 2, so in total that's 4 root 2. So the total ABFE quadrilateral, this is 8 root 2, and the area of the shaded region. No, so let's get to knowing these two. So ACE and DBF, so there are 2 times 1/8 of the whole circle, which is 4 pi. 4 pi. This is pi. And then ACO, ODB, and then since this is 2 root 2 and this is 2, that must mean that this is also a 2. And same thing for here, this is 2 and this is 2 root 2, so this must be a 2. And this must be a 90 since they are tangent. So this is 2 and this is 2, this is 2, this is 2, so that means when this and these are added together, like if this comes over and sticks like this, then it must be a square, right? So a square with sine length 2. So it's 2 times 2 equals 4. So it's these three numbers. This is the whole thing, and we have to subtract these two from it. 8 root 2 minus pi minus 4. This is the same thing as b. So it's 24. And 25 for each positive integer n, let Sn denote the sum of the digits of n for how many values of n is this value, 2007. Okay, so for Sn to be the sum of the digits of n, so since this is 2007, then n would have to be a 4-digit number. So Sn would be maximum. Sn would be at maximum 36 because of 9999. Because it can't get much greater. Because it can't get greater than that. And then so this is a 2-digit number. So there are two possibilities. One where n equals 2000 something, and the other where n equals 19 something. So let's first try it with n equals 2000 something. So if n is 2000 something, then let's start with 2000. N is 2000. Then Sn and Sn is 2 and 2. It's not gonna work. 2001. Then 2 plus 1 is a 3, and SSN is still a 3. So this is going to work. So we've got 1. And then 2002. 2002, this is... Wait, yeah, 2002. This is 4 and then 4. So it just doesn't work. And all the numbers from up here to 2007, they're just getting bigger. So they won't get to 2007. So n is 200 something. We've exhausted that possibility. So it's now 19 something something. But for it to be 19 something something, then the numbers here would be pretty big. And so if they're big, then they would be in the tens digit. So it's safe to say that these might it's safe to say that these would be around 1980 something, right? So let's start with 1980. 1980, this is 18, and 1 plus 8 is 9. So 1980 plus 18, that's 1998 plus 9, that is 2007, so that does work. That's another 2. And then 1981, this is 19, and then this is 10. So this won't work since it's much too big. But the next one, it might work since it gets smaller. 1982, and it's 20, and it's 2, and it's still quite big. No, it's 2004, so it's way too small. Let's go one more. 1983. 1983, this would be 21, this would be 3. So 2007, so it works. So we have one more, 3. And 1984, this would be 22, and then 4. Yeah, so from this time on, like, these are going to get bigger and the others are going to stay constant, right? So it's just gonna get bigger. So now let's try to go down from 1980. There might also be some more. So 1970, 1979, 9. Then this will be 26, and that's way too large, obviously, from the start. And then this would be 8, so it doesn't work. 1978. 1978. It would be 15, no, 25 and 7. It doesn't work. 1977. This is 24 and this is 6, and this does work, so there's 4 now. And then 1976. This would be I don't know, 9, yeah, 23, and it's 5. Yeah, so similarly, these three numbers are just going to get lower and lower, so it won't ever come up to 2007 again. So these 4 values are all we have. And so how many values of n? 4 values of n, so the answer is 4D. And thank you for watching.